So in this video we discuss about the Verilog code of half adder. So how the half adder looks like means it seems like this. So you can see in half adder there is a XOR gate and whereas the AND gate. So for half adder you can see the diagram is like this. For A and B are the inputs. So they are the two inputs for the half adder. We name it as the A and B means we can define it by two variables. So for half adder they are the two inputs and two outputs. So what are the two outputs? And the sum and the carry. So means you can A can take 0 and the B can take 1 means then we get 1 as the sum and carry is 0. So this is our carry and this is our sum. So if you write truth table means for two variables we get 4 combinations. So what are those combinations? 0 0 0 1 1 0 and 1 1. So like that you can, these are the ABs and sum and the carry. So sum for 0 0 the sum is 0 and the carry is 0. For 0 1 the sum is the sum is 1 and the carry is 0. For 1 0 the sum is 1 and carry is 0. And for 1 1 the sum is 0 and the carry is 1. This is the truth table for the half adder. So if you give, how it likes means, so the half adder by using these gates means how you represent means, so there is a sum and then carry. So what is the equation for the sum? A XOR B is the sum and whereas carry is equal to A into B. So like that we can obtain. So 0 XOR 0 is nothing but 0. So 0 into 0 is nothing but our carry. So these are the formulas for half adder. So how you design half adder using Verilog code, just look into that. So this is our schematic like that. So the sum formula is A XOR B and the carry is A into B. So just remember these two formulas, then it will be useful to our code design. So this is our design code for half adder. So how you represent, as same as every video means every code, you have to represent it starting with module and end with end module. So module you have to write like this. So whatever the after module, so what you have to do, you have to write module name. So you have to take any module name, but it is related to code means after few days if you want to recapture that code, then you can understand properly. So it is our module name. So simply for half adder they are the inputs A and B we take and the outputs are sum and carry we see now. So same we can represent the input ports with just simply write keyword of input, it is the input ports. So what are the input variables? So A and B are the input ports. So we can write simply A comma B. So next, what are the outputs? Sum and carry are the outputs. So these are the output ports. So we simply represented by output keyword. So you can simply write the variable sum comma carry and close with curly braces and the semicolon. So close bracket and semicolon. So what you have to do now? So here we can assign means what is the formula for sum? I say A XOR B is our sum formula, A into B is our carry. So this is sum, this is carry. So but as per the Verilog design code, so I already say for logic gates what are the symbols. So for XOR what is our symbol? So it is a cap symbol. So for AND gate the symbol is like ampersand. So we have to use these symbols in the Verilog code. Don't use this plus symbol or dot symbol like that. So in Verilog there are specific characters or operations to perform. You have to use some specific symbols. So I already say in the previous videos what are the symbols you have to use for particular gates. If you don't watch those videos, then go back to those videos and watch them and then come back to this video. Then you have to know what are the gates. So they are nearly some 9 gates, like some nearly 7 or 9 gates like that. So every have some specific symbols. So for here we need only XOR and AND gates. That's why I say for only these two only. So if you want all other means, so you can watch the previous video. So for XOR it is like cap symbol. So you can simply write assign. So assign, why you write assign means, so whatever the value of RHS, it must be assigned to sum. So that's why I have to assign the you have to use assign keyword in the code. So it is like a data flow modeling. In data flow modeling you have to assign some specific values to LHS side. So you have to use assign keyword. So simply write assign. So sum equal to A XOR B. So whatever the operation perform in right side, it will be assigned to whatever the variable in the left side. So you can simply write sum is equal to A XOR B. So the operation will be done and the output of A XOR will be go into the sum variable. So next, assign carry. So what is the carry formula? A and operated with B. So simply the RHS side value is assigned to the LHS side. So simply A and B operation will done and the value is assigned to carry. And simply we can close the module with AND module. So it is about our design code. If you have any doubts, you can comment it. So just look into the test bench code. So as same as the design code. You already know that. So every code is start with module and close with end module. So now look into the after module, you have to must and should mention the module name. So what is the use of these module name? Means you can instantiate and instantiate these module in other module. So that's why module name is maybe preferable. So for complex circuits, it may be so many of codes we have to use, but you have to design simply this code and you can instantiate in other modules. In upcoming videos, we can see those also. So you can simply write module name here. So it is a test bench. That's why I simply mention that half underscore adder underscore TB. So just remember that the module name is never start with any numbers or any special characters like that, and there is no space between the name also. So what I every video I say that, so whatever the input ports, it must be represented in test bench as reg or native data type. But why you specifically mention the reg means, so these values whatever the a and b are used in this initial block, so you can remember that what are the variables we can use in the initial block, it must be reg data type only, not in net data type. So that's why you can use reg here. So if you don't mention it in initial block, then you can simply represent this reg in wire also, so no problem. By you particularly mention reg means, so these variables are used in the initial blocks, that's why you can use reg only. So you can simply, what are the inputs here, you can simply represent inputs in reg data type a comma b, and what are the outputs here, we can see sum and the carry, so you can represent it by while. So not only mention with a only, you can use any name. I already discussed in this topic previous video. So you can avoid the confusion, you can simply represent what are the values you given here, and you can also same represent means, so by value port connections, it will be simple to connect the ports, so no confusion. If you take any different values means, you get confused for what port, what is the connection like that. If you take same variables means, you can simply connect the same variables like this here. So like that, so output you can mention with wire data type. And then next, what is the module name in the design code, it can be instantiated here. So like that, you can connect this design code to this test bench code. So you have to write this line, otherwise you don't get proper values and outputs here. So you simply get high impedance or some unknown values like that. So you can instantiate. So DUT is nothing but our instance name. DUT is not design under test is our instance name. So here it is our port connection. So here it is our port connection. So there are the two port connections. Every video I say that, so there are the two port connection, one by name, another by order or position. So name or order. So here it is like name. So if you want to do order means, so it simply write like a comma b comma sum comma carry. So it must should be in order. So whatever you follow order here, so a b sum carry, whatever the order you follow in the design code, you simply follow the same code in this test bench also. It is like order connection, order port connection. But most probably you have to use name means, so you avoid the some confusions like that. So next we have to simply go into the initial block. So there are the multiple statements in the initial block means, you simply start with begin. So in begin you have to give, in this initial block you can give the what are the some different combinations, and you have to verify the in the output side. So here I take the 0 1 combination and 1 1 combination and 0 0 combinations. I already say these /10 and /10 /5 means those are the delays. So after the any change in the input, if you want to give any delay or some time to change the values, so you can simply use these delays. So slash it is the dollar finish means, it you have to stop the simulation here. So no need to perform after the simulation of 5 nanoseconds means, here there are the 10. So initially they are the 0. So after 10 means, so after 10 seconds, 10 nanoseconds and 10 nanoseconds and 5 nanoseconds, it's simply 25 nanoseconds. So after 25 time unit, the simulation will be stopped here. By using this dollar finish, you simply stop the simulation time. Means no further simulation here. So that's why I use this keyword here. So you can end this begin with end. So if you don't write end means, this begin never ends. So that's why I have to end with end. So next we have to write this 4 lines is I use EDA playground. I already say in previous videos, I use EDA playground for the simulation purpose. If you want to generate the waveforms in EDA playground, you must and should write these 4 lines. That's why I use these 4 lines in this code. So if you do any other Vivado tool like that, so no need to write these 4 lines. Otherwise you can write, if you want to do any program in EDA playground which is an online compiler like that, So if you want to know about this area playground also, you can comment it. If you want a particular clarification, how can I use, what are the simulation I use, how I get waveforms, like that. So if you want to know about this area playground, you can comment it. I will make a particular video how you use and how you type and where you have to simulate, like that I show you. So until then, these 4 lines are used for our waveforms generation. So it stop with end module. So module is end with end module. It is our test bench. So our design code and test bench code is completed. Till now, if you have any doubts, you can comment it. So next we have to go to output waveform. So in output waveform, what are the values we have to take in the test bench that will be generated in this test bench. So this line indicates so these values in the here. So if you want any particular value, simply double tap on the waveform here. So in this scale you can double tap. So then you can simply get the line like this. So what are the values you can represent here. So don't get confused here that don't want to see these lines. So you simply observe the values here. So you get those values here. So you can now check it. So 0 1. So 0 1 means our so now go to truth table. So 0 1. What is our 0 1? The combination sum is equal to 1 and the carry is equal to 0. So sum is equal to 1. Here so you can observe that sum is equal to 1 and carry is equal to 0. So like that we can verify our truth table by giving your different values and take different simulations. So now see, first at t is equal to 0, a is equal to 0 and b is equal to 1. So here first at t is equal to 0, so a value is equal to 0 and b value is equal to 1. So after 10 nanoseconds what we have to do? So here we can see after 10 nanoseconds, the a is equal to 1 and b is equal to 1. So simply you have see that after 10 nanoseconds, so here after 10 nanoseconds the values here will be changed. 1 minute. So here you can see after 10 nanoseconds the a and b values are get changed. So then again when we have to change after 10 nanoseconds. So 10 plus 10, 20 nanoseconds. So after 20 nanoseconds again the values will change to a is equal to 0 and b is equal to 1. B is equal to 0. So let's see after 20 nanoseconds the a is equal to 0 and the b is equal to 0 here. So like that the sum and carry values also according to change with the a and b values. So next after 5 nanoseconds the simulation will be gone. So you can see here after 25 nanoseconds the simulation will be stopped here. So this is our output waveform. Till now if you have any doubts you can comment it. Thanks for watching and until then bye.